All right. Good morning, everybody. Today is Thursday, October 12th, 2017. And this is Before the First Cup with Jules here on UCY.TV. Happy Thursday, everyone. It is a chilly and soggy 53 degrees, pretty dark and miserable here in upstate New York. So where do we leave off on Tuesday? We titled the show AI, Predictive Policing, Minority Reports, and Algorithmic Justice. We had spent the last few shows looking at a progression from healthcare technologies and the Department of Defense involved with the universities and the research and the intelligence agencies and gene editing the population potentially in the not too distant future in ways that you might not even know you're being edited. We had read about some CRISPR pill and some DNA nanobots that they had been working on that could lift and move molecular things inside of your body. They had little arms and legs and could move around. Now, sorry I wasn't here yesterday. I actually had a neurologist appointment. Yay, I finally have a neurologist here in Rochester. One of the things that came out of my appointment yesterday was actually some good news. He said he looked at all my scans, and there were lots of them, and he had determined that my stroke was only caused by one narrowed blood vessel in my brain. The rest of them all looked pretty good, so that was quite a relief. But we started talking about potentially if there is an issue in the future, some of the potential treatments for that. And one of the things that they do is they stent. And I'm not too sure about a stent in a brain blood vessel, but I asked him if he had seen anything about the new golden nanoparticle testing that they've been doing with blood brain vessels. Not that I'd want one of those, but I was interested if he knew anything about it. Where they were using these golden nanoparticles that are smaller than a red blood cell that could go into the bloodstream in the brain and be able to send back feedback and images as to what is in the blood vessel, what is blocking the blood vessel, high resolution imaging that they could be taking then from the outside. Now, of course, he didn't know anything about them. Told him I had a feed, and amusingly enough, before this all happened, I was already reading a lot about different technologies for the brain. So I'm going to start taking a look at some of these new robotic technologies in this medical, scientific, industrial, academic complex that has been rolling out. We've been talking about merging man with the machine for quite a long time, and they're getting pretty close with some of these technologies. Last week or 2 weeks ago, we had talked about scientists building a robot out of actual DNA. Just like an electromechanical robot sent off to faraway places like Mars, we would like to send molecular robots to minuscule places where humans can't go, such as in the bloodstream. Our goal was to design and build a molecular robot that could perform a sophisticated nanomechanical task, such as cargo sorting. The robot had 3 pieces, each individually constructed from strands of DNA. And the first piece is a DNA leg that can move the robot around. The leg consists of 2 feet that can attach to a special surface and move the robot around the body. And only 1 foot can be attached to a surface at a time, so as 1 foot is placed down, the other foot automatically lifts up, giving the robot a kind of walk. The second piece of the DNA robot is an arm that can grab tiny pieces of fluorescent dye. This arm can hold pieces and carry them around the surface. And the final piece is a sensor that can recognize the specific drop-off point and signal the arm to let go. These 3 pieces can work together to sort different colored dye packets. Now, what's even more interesting is when we were looking at ways to get CRISPR inside of the body, one of the ways that we discovered was not just a CRISPR pill, and that CRISPR pill was in the name of combating antibiotic-resistant bacteria and replacing antibiotics that don't work anymore by splicing and dicing harmful microbials in the body. But they also had come up with a way we discovered the other day using a common virus discovered in the 50s called the adenovirus, and to be able to preload that virus with the CRISPR machinery. And once you inhaled it and it got inside of your lungs and your vascular tissue inside of the lungs, it could CRISPR proteins and then make changes to the endothelium, which is your barrier to your bloodstream. Well, I found a website this morning. This is out of the University of Iowa Healthcare Viral Vector Core Facility, in stock adenovirus products. Now let's listen to this. You can get a regular titer of adenovirus, and there's one of many different flavors for $550 for 1,000. I don't know what UL stands for, microliters maybe. And they do all kinds of different things, but I saw that there was one here that was called cherry. I thought maybe it was cherry flavored, but no, it is the cherry fluorescent protein. So if they can get you infected with an adenovirus preloaded with CRISPR, and especially this M cherry fluorescent protein, maybe they can get the little DNA nanobots in you to go sort those fluorescent proteins. I don't know, but it really kind of struck me as sort of synchronous that we have these two technologies that are from kind of different perspectives, looking like they may have a way to work together. So then I ran across a company this morning called Microbot Medical, and they have this one interesting millimeter-sized microbot called the VROB, Life in Motion. The VROB platform technology is a revolutionary, autonomous, crawling micro-robot which can be controlled remotely or be within the body. Its miniature dimensions allow it to navigate or to crawl in different spaces within the human body, including your blood vessels, your digestive tract, and your respiratory system. Its unique structure gives it the ability to move in tight spaces and curved passages, as well as the ability to remain within the human body for a prolonged time. Now, what's frightening about this stuff is, as we've been looking at these intelligence agencies and their infiltration in spy schools to the universities and being able to see some of this cutting edge research that is being done, a lot of this funding we are also finding is being funded by places such as DARPA and the intelligence agency's version of DARPA, and that would be IARPA, and becoming part of the Internet of Things is they get these little mini sensors and robots that can discreetly enter the human body and live there for a very long time, sending back data. It has to make you worry. Now, there is a little microbot that will self-clean shunts, and that would be shunts that are put up into the brain for something called hydrocephalus. That is something that someone in my extended family has, where they have shunts in around the base of their brain to be able to drain the lymph that accumulates because their drainage system isn't working properly. Well, there's now a little microbot that is for self-cleaning shunts. Hydrocephalus, also known as water on the brain, is a medical condition presented mostly in babies in which there is an abnormal accumulation of cerebrospinal fluid in the ventricles of the brain. The same condition, known as normal pressure hydrocephalus, presented mostly in the elderly population, causing thinking and reasoning problems, difficulty walking, etc. The solution is a microbot device that is a robotic system designed as the ventricle catheter position of the cerebrospinal fluid shunt system. The microbot's ventricle catheter can connect directly to valves currently on the market and maintain a proper flow through the ventricle catheter. It is expected that this device will replace all ventricle catheters while drastically reducing and eliminating shunt occlusions. Now, this is frightening because replace all ventricle catheters. So does that mean that the people that have these ventricle catheters are going to have these little micro robots put into their brains? I think that's what it means. Well, listen to this, talking about catheters. This was a new little microbot out of a publication called medgadget.com. A self-propelled catheter for lung biopsies. Scientists at Tokyo Institute of Technology have developed a self-propelled catheter which can move like an earthworm and could help doctors reach areas of the lung that can be tricky to assess using conventional bronchoscopes. At the moment, if doctors want to take a closer look at a lesion in someone's lungs, they typically have to use a bronchoscope. This is a thin, flexible tube containing a camera, a light, and other tools such as forceps that the doctor pushes down a patient's airway and into the lungs. Bronchoscopes allow doctors to perform a variety of tasks, such as taking tissue samples from a suspected tumor. However, the airway becomes progressively smaller and more complicated as they branch deeper into the lungs. It takes a lot of skill for a doctor to operate a bronchoscope to find and manipulate lesions deep in the lung, and even choosing the right pathway through the branching lung becomes ever more difficult the smaller the branches get. Oh, hold on. I just clicked off of my page. Oh, shit. Hold on one second, guys. Oh, here it is. I moved to the wrong place. The researchers hope to eventually incorporate a camera and other tools, blah, 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 blah. The work has not yet been published, but it was presented at the 2017 Japan Society of Mechanical Engineering Conference on Robotics and Mechatronics in Fukushima, Japan, which I found interesting as well. So I ran across another story out of that very same publication. Implantable, biodegradable optical fiber to stay in body for long stretches of time. Light delivered via optical fiber is used in medicine for tasks such as examination of tissues and destruction of tumors and optogenetics. And many other applications are on the way, including drug release and activation, optogenetics, ding ding, and new diagnostic modalities. Some of these may require a source of light to be available for long periods of time. And a major challenge with the use of traditional fiber to reach targets deep inside the body for extended periods is that it's always usually made of brittle, non-biodegradable glass. It is therefore has to be removed. And eventually, without leaving any parts behind, now the University of Pennsylvania researchers have developed a completely biodegradable step index optical fiber out of citrate-based polymers. Step index fibers feature a central channel through which light passes and an exterior coating that prevents light from escaping. And it can be used to deliver light and to look at objects at the distant end of the fiber, just like a little catheter. And both the inner layer and the outer have precisely the same mechanical properties, which means that the total fiber can be bent and stretched without having two layers separate from each other. Additionally, the layers are biodegradable at a similar rate with each other, disappearing into the body and leaving it via normal and commonly used channels. We believe this new type of biodegradable, biocompatible, and low-loss step index optical fiber can facilitate organ scale light delivery and collection, and that it will become an enabling tool for diverse biomedical applications where light delivery, imaging, and sensing are desired. How nice. It can stay in your body for long periods of time, and it is fully biodegradable. So then this led to this one, and this story I actually found yesterday before my neurologist appointment. This is out of cbc.ca. So this is the Canadian news channel CBC. We used to watch these guys in Buffalo when we used to have an antenna on the roof. A microbot a day keeps the doctor away. Scientists close to perfecting edible gelatin nanobots. So it's not just edible CRISPR pills anymore. No, it's edible gelatin nanobots. New and improved vitamins, now with more robot. The advent of robotic technology has put the career prospects of doctors somewhere on the same uneasy spectrum as the rest of us. Forecast uncertain. And remember, the robots are going to take all the jobs, including the white-collar ones. One thing is sure, though, Flintstones vitamins are going the way of the cavemen. Researchers are inching ever closer to a nutrient delivery system that could literally troubleshoot illnesses out of your body or just make sure that your potassium levels are on point. Edible, gelatinous, and built with power to heal and nourish from within, parents of the future could be ensuring their kids have taken their nanobot every night. Any readers tempted to balk at the idea as a far-fetched science of tomorrow should consider this, in fact, this is the science of today. Just last week in Vancouver, during the International Conference on Intelligent Robots and Systems, researchers shared their prototype for a, quote, gelatin-based actuator in which the robot science speak for tiny gummy robot legs, kind of, and presenters from Switzerland, École Polytechnique Fédérale de Lausanne, explained that the boxy-looking caterpillar would allow a nanobot to meander about your inner workings, dispensing vitamins, medication, and medical procedures at will. The dawn of the micro health sentinel. And interestingly, as many experts don't like the idea of robots near our bodies, let alone in them. Actuators allow for the mechanized mobility. Again, think caterpillar legs or a tank tread. Whatever your thoughts on ingesting what essentially looks like a robotic bug, the usefulness of a health bot you swallow could provide broad support. The researchers report that the components of the such edible robots could be mixed with nutrients or pharmaceutical components for digestion and metabolization. Or, laser blast anything that looks malignant. Hopefully their aim is pretty sharp. And what happens to the beneficial bot when his duty is done? Well, you digest it, of course. And experts behind the actuator added potential applications and disposable robots for internal exploration, digestible robots for medical purposes in humans and animals, and food transportation where the robot does not require any additional payload because the robot is the food. Oh, God. The potential boon for the preventative medicine in humans, the applications extend to zoology as well. Fully edible robots would help to study how wild animals collectively behave. The robots could also take a role of animals' prey to observe their hunting behaviors or to train protected animals to do predation. In case that needs clarification, yes, that means robots teaching predatory and protected species, like, say, wolverines, on how to hunt. A nice wrinkle to add to your own robo-apocalypse nightmare scenarios. Still equal parts awesome and terrifying. Make mine cherry-flavored, and this author, not me, is in. Ultimately, the goal of poppable robotics is decidedly a positive one, only in this author's eyes. Once medical components are mixed into an edible composition, the robots could help preservation of wild animals or heal the inside of the human body. So there you have it, people. Edible nanobots coming to a doctor's office near you someday. And this was from October 10th, 2017. So now take one more step forward. There was a story that came out the other day that caught my attention, and it was in regards to little mini brain balls. Remember, we've talked about mini brain balls before. Well, they're still working on mini brain balls. Synthetic organs, or what they call organoids, nanobots, and DNA scissors, the future of medicine. And this is out of the University of Cambridge. Nanobots that patrol our bodies, killer immune systems, hunting and destroying cancer cells, biological scissors like CRISPR that cut out defective genes. These are just some of the technologies that Cambridge University researchers are developing, which are set to revolutionize medicine in the future. In the new film to coincide with the recent launch of the Cambridge Academy of Therapeutic Sciences, researchers discuss some of the most exciting developments in medical research and set out their vision for the next 50 years. Professor Jeremy Baumberg from the Nanophotonics Center discusses a future in which diagnoses don't have to rely on asking a patient on how they are feeling, but rather are carried out by nanomachines that patrol our bodies, looking for and repairing problems. Professor Michelle Oyen from the Department of Engineering talks about using artificial scaffolds to create off-the-shelf replacement organs that can help solve the shortage of donated organs. And Dr. Sanjay Singha from the Wellcome Trust MRC Stem Cell Institute sees us using stem cell patches to repair damaged hearts and return their function back to normal. I still say stem cells are where it's at. Dr. Ella Desir Russell from the Cancer Research of UK Cambridge Institute describes how recent breakthroughs in using CRISPR-Cas9 will enable us to snip out and replace defective regions of the genome, curing diseases in individual patients. And lawyer Dr. Kathy Little from the Cambridge Center of Law says that research around law and ethics will help us to make gene editing safe. Wink. Professor Gillian Griffiths, director of Cambridge Institute for Medical Research, envisages us weaponizing killer T cells. That was something that DARPA was spending time on, which are your important immune cell warriors, to hunt down and destroy even the most evasive of cancers. All of these developments will help transform the field of medicine, says Professor Chris Lowe, director of the Cambridge Academy of Therapeutic Sciences, who sees this as an exciting time for medicine as he evilly rubs his hands together. New developments have the potential to transform health care, quote, right the way from how you handle the patient to the actual delivery of the final therapeutic product. And that is an exciting thing, he says. Well, making little mini organoids to test drugs, that seems to be the newest, biggest, and greatest thing. Little mini brain balls are at work again. Scientists discover neuronal effects of psychedelic drugs using human mini brains. And this is out of futurism.com from October 9th, 2017. New research using human mini brains and a hallucinogenic compound have revealed the beneficial neurological roles that these psychedelics might play. These molecules could increase proteins related to learning and memory and decrease proteins connected to brain degeneration and inflammation. New research using human mini brains has revealed that a hallucinogenic compound known as 5-MeO-DMT, and I think that's more affectionately known as DMT, triggers changes in neuronal signaling pathways associated with inflammation, neuroplasticity, and neurodegeneration. The discovery is critically important now because various studies have found benefits from psychedelic use, but have been unable to parse out how and why these compounds have produced specific positive effects. For the very first time, we could describe psychedelic-related changes in the molecular functioning of human neural tissue, says Steve Ruhan, study leader and head of the research at the Jor Institute of Research and Education. Although past research has demonstrated that psychedelic substances, including ecstasy and LSD, may impart antidepressant and anti-inflammatory effects, scientists lack the tools to prove why. The specific molecular pathways that psychedelic targets in the brain had not been identified. But to solve this problem, researchers in this study used cerebral organoids, more affectionately known as mini brain balls, a 3D culture of neural cells that resemble a human brain, still in its developing stages. The team exposed these human mini brains to single doses of DMT to identify which pathways the molecule might affect. The team found that the psychedelic drug changed the expression of almost 1,000 different proteins. Next, they mapped out what roles these proteins played in the human brain. The team then discerned a clear pattern in their results, and exposure to psychedelic downregulated proteins connected to brain lesions, degeneration, and inflammation. This hinted that the molecule and similar psychedelic substances may play a neuroprotective role in the human brain. At the same time, DMT caused an upregulation of proteins critical to synaptic formation and maintenance, including proteins connected to cellular mechanisms for learning and memory. Results suggest that classic psychedelics are powerful inducers of neuroplasticity, a tool of psychobiological transformation that we know very little about, says Siddhartha Nurbito, study co-author and director of the Federal University of Rio Grande do Norte Brain Institute, in a press release. And it was interesting because the intelligence agencies and the CIA probably know about the neuroplasticity and psychobiological transformation of LSD use from their MK Ultra studies at Harvard. But we won't mention that one. Professor and co-author Duraglio Ajulo added that the study suggests possible mechanisms by which these substances exert their antidepressant effects that we have been observing in our studies. In the U.S., these psychedelic substances remain heavily restricted, although new research may be changing minds. The FDA's recent determination that ecstasy is a quote-unquote breakthrough therapy for post-traumatic stress disorder, for example, may motivate lawmakers to dismantle some of the legal roadblocks, not robots, to accessing these drugs. This research should further in the trend, says, and Rain confirmed in our release, our study reinforces the hidden clinical potential of substances that are under legal restrictions, which deserve attention by the medical and scientific communities. So then to continue on our tangent of looking at the brain, mad science gone mad, brain scientist Christoph Koch maps out a path to merge humans and machines. And this was dated October 10th, 2017, out of geekwire.com. Bot or Not. This is a special series exploring the evolving relationship between humans and machines, examining the way that robots, artificial intelligence, and automation are impacting our work and our lives. It may sound like a zombie movie, but Seattle's Allen Institute for Brain Science, ding ding, Paul Allen, co-founder of Microsoft's, is studying fresh human brain tissue to see close up how neurons work, and perhaps eventually figure out how to meld minds with machines. Integrating artificial intelligence chips into our own neural wiring may be the best way to address concerns about the rapid rise of AI and the potential that the machines could outpace humans, says neuroscientist Christoph Koch, the Institute's chief scientific officer. So here we have another one. Paul Allen, Institute for Brain Science, the chief scientific officer, is thinking that our only way to compete is to join them. Studying the brain should be a matter of great urgency, whether you believe that AI will lead a work-free paradise or a Terminator-style nightmare, Cook said today at the 2017 GeekWire Summit. Cook emphasized that the focus of his research is the biological brain rather than its artificial equivalents, but he says it was clear that human-level AI was decades rather than centuries away. And if that is the case, the pace of change could overwhelm the ability of individuals or societies to cope, he said. Statistics point to a significant shift ahead in employment, with truck and taxi drivers, as well as fast food workers, likely to feel the brunt first, as well as doctors and neurosurgeons and cancer doctors and lawyers and all those other jobs that we have outlined where the robots are going to take eventually. Cook doesn't think that it is likely that the shift to robotic workers will make things easier for humans. Life speeds up, he says, and it's going to get ever more hectic for those who still have jobs. And if AI goes down the wrong path, the technology could lead to greater economic inequality, social instability, and wars fought with weaponized thinking machines. And if we think long term about the future, 20, 30, 40, or 50 years from now, it is very unpleasant. It is very fuzzy, says Cook. Can two intelligent species, one biological and one artificial, share the planet? Cook is doubtful about that, ding, but he sees the potential for an alternate scenario. One very real possibility is that we have to understand how our brain works, and we have to engineer the shit out of it, says Cook. And that is where the Allen Institute for Brain Science, created by Microsoft co-founder Paul Allen, plays a role. For 14 years, the Institute has quietly been studying how human and animal brains work on the physical level as well as the genetic level. And one of the Institute's projects involves taking bits of cortical tissue extracted during brain surgeries at Seattle hospitals and then running them through experiments while the brain cells are still fresh. This is not a mouse brain. This is a piece of living human brain, says Cook. 20 minutes ago, it was actually part of somebody's brain with somebody's memories of their first kids, but now it's here in the lab, and we can look at the morphology, and we can study it in great detail. Isn't it disturbing that this is an institute from a former co-founder of Microsoft that is studying real-time human brain tissue that was extracted from somebody's brain at the Seattle hospital, and it's still living in a petri dish? Cook says that the database of human brain cell reconstructions, including 3D imagery, would be made freely available via the Institute's website later this month. And we had read about this actually last week when we looked at the Apollo project of the brain, sponsored by IARPA for the neuronal barcoding project. And the 3D imagery was being created by the Allen Brain Institute. And as this database grows, researchers can use the reconstructions to model how electrical fields might affect brain function or precisely what happens to brains of patients with Alzheimer's disease. It is going to be a long road ahead, says Cook, but eventually neuroscientists could gain enough of an understanding of the nervous system circuitry to restore lost functionality. Researchers have already found ways to rewire paralyzed limbs, and that was DARPA, so that they can respond to brain commands and even provide sensory feedback, although the apparatus that's been developed so far is too bulky for practical use. And I thought we read about some new brain-computer interfaces that made limbs very realistic. Cook thinks it is only a matter of time before brain-machine interfaces become small enough and capable enough to restore full function to a patient's nervous system, and even go a little bit further. We are all interested in also enhancing our own performance, he said, because I think that is one way we can continue to compete against our own creation. So this is the challenge for this century, really. Last century was called the century of physics. This century has really been called the century of biology, and particularly in brain science, trying to understand our brain and to cure diseases, but also enhance our brain for our long-term survival. Cook isn't alone in his view. Elon Musk, billionaire CEO of SpaceX and Tesla, is also backing his venture called Neuralink that is a focus on developing powerful brain implants. If you can't beat him, join him. And after his talk, Cook told GeekWire that he was on board with Musk's vision for the future brain chip. In general, that is the right way to go, says Cook. The question is, how long is it going to take? Particularly, the regulatory hurdles are big. Anytime you drill a hole in somebody's brain, you better have a good reason for doing it, typically because it is a health danger. And we read all about brain implants a few weeks back. But remember, they don't have to drill a hole anymore with ECGs. They can take all kinds of readings. And with some of these edible DNA bots that they can get into your bloodstream, you'll be able to have non-invasive technologies that'll be able to feed back information as well as interact with the living creature. Cook speculated that Musk might be among the first people to get a brain chip purely for the purpose of mental enhancement rather than to restore lost neural function. All it takes is well-known people, maybe like Elon Musk, he says, yes, I'm going to put a chip in my brain, and it's going to take some surgeon, no matter when, to see if it can be done. And I think now people who do these things, you will then suddenly see thousands of people everywhere who will want to do it. So yeah, let's use celebrity to sell some of these technologies. So I did a little search on the Allen Institute of Brain Science, And there was a publication called ContractDesign.com, March 3rd, 2016, Allen Institute for Brain Science. Co-founders, Microsoft's co-founder Bill Gates and Paul Allen, two of the richest men in the world, have built headquarters for their respective foundations just blocks away from each other in Seattle's South Lake Union neighborhood. Recently completed Allen Institute for Brain Science is located just a short walk east of the Bill and Melinda Gates Foundation. And while Gates focuses on global health issues, the scientists at the Allen Institute are unlocking mysteries of the brain. Their latest findings are uploaded to the Brain Atlas, which is a web-based open data source available to the world. And the challenge for Perkins and Will in designing the Allen Institute was to balance the insular workings of a research institute while expressing the openness of the foundation. So this must be some sort of architecture publication. Until this new headquarters was completed, the Allen Institute scientists were in less than ideal space for separate structures around Lake Union. This brand new 272,000 square foot institute is on a prominent block, which was once the home of a terracotta-clad automobile dealership dating back to the 1920s. The landmark dealership facades, as well as the showroom interiors, were disassembled, stored off-site, and then reconstructed. Perkins and Will stepped the new metal and glass structure away from the historic reconstruction, which is now a space at an art gallery, and a retail. So I don't think we need to really read about the architecture of the facility, but it's just down the block from the Bill and Melinda Gates Foundation. Well, now check this out. March 10th, 2016, IARPA awards $18.7 million to the Allen Institute for Brain Science as a part of a project with Baylor College of Medicine and Princeton University to reconstruct neuronal connections. Now, wait a second. This was the Microns project that we read about last week, and the Allen Institute got a nice big fat contract for it as well. The largest reconstruction of connections between cortical brain cells ever created will shed light on how the brain computes information. The Intelligence Advanced Research Project Agency, more affectionately known as IARPA, has awarded an $18.7 million contract to the Allen Institute for Brain Science as a larger part of a project with Baylor College of Medicine and Princeton University to create the largest ever roadmap to understand how the function of networks in the brain's cortex relates to the underlying connections of the individual neurons. Remember, this is also part of the project that George Church is working on, with part of the barcoding neurons with Harvard. This project is part of the Machine Intelligence from Cortical Networks, more affectionately known as Microns program, which seeks to revolutionize machine learning by reverse engineering the algorithms of the brain. This effort will be the first time that we can physically look at more than 1,000 connections between neurons in a single cortical network and understand how those connections might allow the network to perform certain functions like process visual information or store memories, says Clay Reed, PhD, senior investigator at the Allen Institute for Brain Science. The ultimate goal is to implement the algorithms and the learning rules that the scientists decipher from the brain to advance the field of artificial intelligence. The artificial neural networks have recently developed capabilities to do things such as speech recognition, recognize faces, and analyze big data for biomedical research. However, in many ways, these artificial neural networks are still primitive compared to their biological networks of neurons and do not learn the way real brains do. Our goal is to fill this gap and apply the algorithms of the brain to engineer novel artificial networks and architectures. Experiments for the project will begin at Baylor College of Medicine, which is in Texas, Dallas, I believe, where researchers will perform studies to identify neurons that respond to particular patterns of visual stimulation, such as lines and different orientations on a screen. The experiment will continue at the Allen Institute for Brain Science, where sections of the same brains will be stained, sliced, and imaged in an array of electron microscopes, which captures the intricate details of the neurons and their connections. The data that we are collecting is massive, and with the work of having virtually no margin of error, if we lose 2 slices of brain in a row, each of which is vastly thinner than a human hair, we cannot hope to reconstruct the segment faithfully in 3 dimensions, and we'll have to start over. This is where the Allen Institute's history of processing and scaling data effectively at an industrial scale is so crucial. And I wonder if they have a back end of Microsoft servers that are crunching all that big data. Finally, the 3D image data will be sent to Princeton University under Sebastian Sung, PhD, where it will be painstakingly reconstructed in 3 dimensions by human annotators aided by powerful machine vision and machine learning algorithms. Each individual neuron with all of its myriad processes will be traced and analyzed. We are delighted to be collaborating on this exciting project with our superb scientific colleagues at Baylor and the Allen Institute, says Sung. The end goal of the project is to recreate a reconstruction of a cubic millimeter size of brain tissue, the size of a grain of sand, yet containing the largest section of brain ever to be studied in this way to date. This work is the next big step in understanding how networks in the brain work. And for the first time, we were able to come to grips with cortical networks and all their complexity rather than just a little bit at a time. No other technique can hope to grapple with their richness. So there you have it. The U.S. government launches a $100 million Apollo project of the brain, and this would be in cahoots with places such as George Church, Baylor College, and we read about a few other places, Princeton, and that went on and on and on. And then as we have all these technologies that can read the brain, get into the brain, be able to read thoughts from the brain, it makes you wonder where these technologies will be headed. Now, here's a good question. So why do they care so much about neural networks? Well, here they answer why neural networks are smarter than the usual computer. In the Neuroinformatics 2017 conference is being held from October 2nd to 6th. And they interviewed one of the main conference participants, Alexander Gorban, who is a DSc in physics and mathematics and an expert in the field of neural networks. The first such conference was held at the initiative of 3 institutions, the National Research of Nuclear University, the Cohen Research Institute of Neurocybernetics, and the Institute of Computational Modeling and the Siberian branch of the Russian Academy of Sciences. This year now marks the 19th anniversary of this conference. Neural networks are networks that consist of simple interconnected nodes of artificial neurons, biological neurons, which can be found in our bodies, are cells that store, transmit, and process information through electrical and chemical signals. The network's complexity, performance, flexibility, and other important characteristics are determined by connections between these neurons. The neurons in artificial neural networks are nothing but a very simplified model of the neuron found in biological neuronal nets, and each of these neurons is a simple node that transforms and transmits signals. We can say it is the structure of their connections that plays the central role in this process, not the properties of the interconnected nodes. The net built from formal neurons can be effectively analyzed on many parallel systems, achieving maximum speed. And the main advantage of neural networks is they are great at parallel computing. It is very important that they learn easily, too. Neural networks learn by drawing their own conclusions from examples that we give them. And that's how they are teaching a lot of this AI right now. So one of the most popular fields right now in neuroscience is building neural networks. Artificial neural networks will reproduce like humans, believe in God, separate into men and women, and have Eastern and Western mindsets. No, it is not a joke. It is actual scientific opinion. An artificial neural network is a new high potential branch of artificial intelligence which is built on the analogy of how human nerve cells are interconnected. This type of structure receives feedback from its actions and is thus capable of self-learning. Artificial neural networks can take on certain functions of human intelligence, for example, select and make optimal decisions on the basis of earlier gained experience. And while neurons send electrical impulses to one another, an artificial neural network elements use binary code. A distinctive feature of a neural network resides in its ability to learn and become smarter. And this is what we're creating, guys. And can an artificial neural network grow so clever that it will gain consciousness and self-awareness? Well, very good question. On the sidelines of the CIPR conference in Russia, Doctor of Psychology and Economics, neuropsychologist Professor Alex Suchnov outlined for Sputnik the necessary conditions for personality formation. Personality is educated. Personality is shaped by personality. A conscience emerges when the human brain is influenced by a social model. There must be an understanding of the dichotomy of life and death. There must be an understanding of the differences between pleasure and pain, and different mindsets, Western versus Eastern, for example, should be formed in neural networks. Programmers will form a network using linguistic analysis and literature, which will shape the mindset of a given network. And there must also be a separation into female and male networks, or even 3 or 4 sexes for faster development. Sinkoff recalled that life on Earth came into existence some 3.7 billion years ago, or so he says. But sexual reproduction, which was the formation of a new organism from the combination of the genes of 2 others, only appeared 540 million years ago. This is a huge evolutionary advantage over asexual reproduction, because in this case, the offspring is the copy of its parent. But because this provides a greater variety and more chances for adaptation to the environment in the conditions of rivalry, given species evolution, development goes much faster with genes from 2 of a species. The specialists stress that only after these conditions are established will neural networks be able to follow a similar path to human civilization. Now, 1 second here, because I thought we already found out that there were synthetic DNA that were able to reproduce. Hold on, synthetic DNA and reproduce. And we also found out that there was evolution that was seen with mommy robots creating baby robots. Scientists create artificial life, synthetic DNA that can self-replicate. And that was in 2010. Oh, great. One of the biggest breakthroughs in recent history. Scientists have created a synthetic genome that can self-replicate. So what does this mean? Are we about to become gray goo? Well, led by Craig Venter of the J. Craig Venter Institute, a team of scientists combined 2 existing techniques to transplant synthetic DNA into a bacteria. First, they chemically synthesized a bacterial genome. Then they used a well-known nuclear transfer technique, which is the same technique used in vitro fertilization, to transplant the genome into a bacteria. And apparently the bacteria replicated itself too, so it's not sexual, it's asexual reproduction, thus creating a second generation of the synthetic DNA. This process is being hailed as revolutionary. Researchers created a synthetic genome by copying an existing one of the mycoplasma myconoids and then transplanting it into a mycoplasma capillum. How can we be sure that the mycoplasma myconoids is synthetic? Well, when creating it, the team added a number of non-functional watermarks to the genome, making it distinct from the wild version. So they gave it a little logo. And once implanted, the M. myconoids genome booted up the recipient cell, deleting or disrupting 14 genes. The bacteria went on to function normally, meaning that the transplant worked. This is the first synthetic cell that has been made, and we call it synthetic because the cell is totally derived from a synthetic chromosome made with 4 bottles of chemicals on a chemical synthesizer, starting with information on a computer, says Ventnor. This has become very powerful in trying to design what biology we want to do, and we have a wide range of applications in mind. If the method described here can be generalized, design, synthesis, assembly, and transplantation of synthetic chromosomes will no longer be a barrier to the progress of synthetic biology. At present, this is a proof of concept, but it has some immense potential for the future. The researchers at the Craig Ventnor Research Institute have been working on this technology for approximately 15 years. I think they got a big grant from DARPA as well to create an assembly line of creating life on the fly. We now have a number of possible organisms planned. One would be an algae that would suck up carbon dioxide and excrete hydrocarbons for biofuels. Another one would be faster vaccine production. Another one for water cleansing, and another to use light energy to create hydrogen gas from water. And as anyone with even a glancing familiarity with science fiction knows, self-replicating technology could lead to disaster, and I would second that opinion. The Craig Ventnor Institute has done their due diligence here, so don't worry about that. And all their engineered creations require nutrients found in the lab to survive. Isn't that what Oxitec did? And then they found out that tetracycline was also widely available in the environment. Whoops. So they have also created the technology to make suicide genes that will prevent synthetics from living outside of a controlled environment. And aware of the ethical and security issues involved, the Craig Ventnor Institute has also been involved with talks with the U.S. government since 2003, and as well as being reviewed by independent bioethics groups since 1997. Now, hold on. Ventnor, and DARPA. Here we go. We'll find this one. DARPA and Ventnor launch an assembly line for genetic engineering. I knew it. I remember this one. This was just 2 short years later, May 22nd, 2012, out of Wired magazine. DARPA and Ventnor launch an assembly line for genetic engineering. The military-industrial complex just got a little bit livelier, quite literally. That is because DARPA, the Pentagon's far-out research arm, has kicked off a program designed to take the conventions of manufacturing and apply them to living cells. Think of it like an assembly line, but one that would churn out modified biological matter, man-made organisms, instead of cars or computer parts. This is part of what DARPA affectionately called the Living Foundries program that was first announced in 2011, and now DARPA has handed out 7 research awards worth $15.5 million to 6 different companies and institutions, and I think one of them was also the Weiss Institute with George Church. Among them are several DARPA favorites, including the University of Texas at Austin and the California Institute of Technology. 2 contracts were also issued to the J. Craig Ventnor Institute. Dr. Ventnor is something of a biology superstar. He was among the first scientists to sequence a human genome, and his institute was, in 2010, the first to create a human cell that could reproduce with an entirely synthetic genome. Living Foundries aspires to turn the slow, messy process of genetic engineering into a streamlined and standardized one, and of course, the field is already a burgeoning one. Scientists have tweaked cells in order to develop renewable petroleum and spider silk that is tough as steel, and I think that was out of the spider goat. Remember the spider goat? And a host of other companies are investigating the pharmaceutical and agricultural promises that are lurking, with some tinkering, of course, inside living cells. But those breakthroughs, while exciting, have also been time-consuming and expensive. And as DARPA notes, even the most cutting-edge synthetic biology projects also often take 7+ years and tens of hundreds of millions of dollars to complete. Ventnor's synthetic cell project, for example, cost an estimated $40 million. Synthetic biology, as DARPA notes, has a potential to yield new materials, novel capabilities, fuels, and medicines. Everything from fuels to solar cells to vaccines could be produced by engineering different living cells. But the agency isn't content to wait 7 years for new innovation. In fact, they want the capability for an on-demand production for whatever bioproduct suits the military's immediate needs. And that was the DARPA lady talking about terraforming Mars and being able to push a button and create life on the fly. To do it, DARPA will need to revamp the process of bioengineering from the initial design of new materials to its construction to its subsequent efficacy evaluation. The starting point, and one that the agency-funded researchers will have to create, is a library of modular genetic parts. Standardized biological units can then be assembled in different ways, just like Legos, to create different materials. And once that library is created, the agency wants researchers to come up with sets of parts, regulators, devices, and circuits, just like the Brain Project, that can reliably yield various genetic systems. After that, they also need to test platforms to quickly evaluate new biomaterials. Think of it as a biological assembly line. Products are designed, pieced together using standardized tools and techniques, and then tested for efficacy. The process, once established, ought to massively accelerate the pace of bioengineering and cut its cost, and the agency is asking researchers to compress the biological design-build-test cycle by at least 10 times in both time and cost, while also increasing the complexity of systems that can be designed and executed. No doubt, DARPA is making some big tasks of the scientists tasked with this research, and not everyone is convinced they can pull it off. The biology will fight them, says Daniel Durrell, program manager with the U.S. Department of Energy, which suggests it might be a few years at least before DARPA's biocreations try to fight us or create some new robotic life form. All right, guys. Well, I can't even believe it, but that was a full hour. Make sure you stick around because it is Thursday. There's all kinds of great radio today. We have Lonnie Clark up next. We have Ron with Game On tonight. We have Hal's show from this week, Thursday, and Jake Anderson should be live tonight. And lots of great stuff that I am working on cutting for you this weekend. So I am about done now. I don't know. I ran out of stuff to talk about today. So make sure you stay away from your CRISPR pills, your little edible gelatin microscopic robots that are one day going to deliver medicine and biosensors inside of your body. Anything that is DARPA, IARPA, George Church, Harvard University, Stanford, Penn U, Princeton, Baylor, that wants to get inside of you, ask some questions about what's in it. All right, well, I don't know where my bumper is, so I'm going to sing here. Oh, there we go. All right, guys, have an awesome Thursday, and I will catch up with you too.